Good day, guys. Welcome back to my YouTube channel. Let us deal with fluid mechanics N6, still under the century, still under the reciprocating pump. It's been a while not posting a video. I was still busy. I want us to look at this. You can quickly go to page 46. You can go to page 46 if you have this textbook. If you are using this type, can quickly go to page 46. I want to explain something here. Right, quickly go to page 46. Right, so there's an important thing that you must know. In the previous video, we have learned about indicated diagram, right? The effect of friction and acceleration on the suction pipe and also the delivery pipe, right? So I want us to look at this. I want us to check at the pressures in the cylinder. Can come, let's check the pressure. In cylinder. Right. I want us to check this pressure in cylinder. You must understand this. So let's start by suction stroke. Remember, pressure when you have a cylinder, this is suction stroke. If you did diesel, you know when you have a piston, you have a suction stroke. There is a suction stroke. Let us start by suction. It's when you suck in the fluid. Is the first stroke here. First stroke. Or it's an induction stroke. This one is a suction stroke. This happens on the suction pipe one. Take place. Okay, you must know this diagram. I want to explain this diagram. Let us have atmospheric pipe, a pump, center line. I want us to have a pump center line. Then on this pump center line, we have an area. Actually, this is a half of an indicated diagram, but we are focusing on the section of the suction. Then you must have this. You must know this. Remember, from the zero line, if you draw horizontally absolute line here, absolute zero, from the absolute zero, or datum line, you can call it datum line, right? So here, that means here from here is zero here. So here, so construct, you know, from here up until to the center of the pipe. You know, this is what it's a atmospheric. It's a H due to atmospheric. It's a head. It's a head due to atmospheric pressure. Then we know we'll have on the suction. Remember, on the suction we're supposed to have here we can construct, come here and construct to in the middle, construct a line, right? We have how many line? 1, 2, 3. We have 3 horizontal line. On this line, you must know, I've shown you this. We're focusing on the suction, right? This distance from here, from the absolute, from the center of that thing, we must know this must be, it's H. It's a head due to delivery. H as small capital H there. And then we must know that here, remember, from here until somewhere here, remember there will be you construct, remember this will be acceleration must take place. Remember, the head due to acceleration must take place at the start here. You have something, a line like this. You have a line like this, and this from here until here, this little piece, you must know that is HAS. HHS is a head due to acceleration at the suction. Then remember, now we're dealing with the suction stroke. At the suction stroke, it's where we have H separation. It's only occur. It's here, the little one here. This you must know. This is H sep. Yes, have H sep. H sep, that one, which is separation hand. This take place only during the suction stroke, right? So this portion, you must know here, this portion, there must be a pressure here. The pressure of the cylinder here. Pressure in cylinder must occur, must take place. Yeah, if you know this, I want to explain. Okay, this structure is there on your textbook. Check this structure. So one thing you must notice, pressure. Let me just erase. Pressure must be this level from the H separate. You can do like this, hidden detail like this from the bottom, right? Then I will do like this. Let me just want to show you this portion. This will be the pressure. This is pressure in cylinder. This is the pressure in cylinder. This portion from, that means H separation, right, must be equal to what? The pressure in cylinder, right? The H separate must be equal to the pressure in the cylinder, because they are on there. It is here. You can do this with this in detail. This is the pressure in the cylinder, that portion that I've sectioned it. So that is what is the H sep, right? H sep is a pressure in cylinder, but now since it will be equal to the pressure in cylinder, you cannot apply. We know that pressure, we're supposed to have what? A pressure head, right? When there is pressure, must have what? A pressure head. If there is a pressure, must be a pressure head. So in other words, since this is a head, we can equate this with head. Then therefore we can say H separate must be equal to the pressure head, right? Here it's a must be equal to the H sep must be equal to the pressure head. From, if you check this portion of the line, we have something like this. This is H sep. Then I did like this. See, this portion is they are equal. Is what you must know. During the suction stroke, H separate is equal to pressure head. They are equal. Then according to the diagram, they are what? They are equal. So you understand? So they are equal. Hence, since they are equal, we know that if we want pressure head, remember this from here until here. Let me just show you a little line here. From here until here, also this must be what? Must be a pressure head. Is this? It's a pressure head in the cylinder. This portion, but this portion is the H sep, right? So since we have this, we know this is equal to this. But now, how can we calculate? I want us. How can we calculate? Remember this line. Check this line here, look at this portion. We have this thing, like right from the top. I want you to check something. If we use logic, if you have something like this, I want us to focus on this part, right? You have H80, right? Since you have H80, here we have a straight line, right here, horizontal line. From this horizontal until here, this portion, we have what? This is HS, right? Then there's a little portion, this portion until here, we have HAS. Then this little portion until there, we have what? H sub. So, do you see that if we can add from here, let me do again the line like this, horizontal. If we add 1, 2, 3 must be equal to the H80. You see that if we add, those must give us H80. You see that if we add, that must give us H80. What I'm trying to say, H80, the big one, this you see most the distance from here must be equal to the sum of these distances. H80 must be equal to the sum of these. Here you see we have HS plus the sum HAS plus H separation. So you see, now if we want to make H separation the subject of the formula, look, I want to make this the subject of the formula, will be H sep, right? I make it the subject of the formula. This will be equal to H80. You subtract all this, and when you transpose, you will subtract HS minus HAS. So you see how we came about this formula. Also remember, H separate, this is a separation, is equal to pressure head. That means also you can say pressure head, you know, pressure head, right? You can say pressure head must equal to H80 minus HS minus HAS. You see, hopefully you understand that. You see, can see. Remember, this A80 is atmospheric, it's a head due to atmospheric. HS, this H, little small letter H, S is a delivery. It's a head due to suction. It's a head that occurs to the suction head. This is the acceleration. When this A, it's acceleration due to what? To the suction part. This is not, it's an atmospheric because there's a capital. You see, this is big H. There's a difference between big H and small h, right? So you know you have this formula. You can screenshot, you can screenshot that so that we can quickly do. I can show you we can delivery so that we can do to, okay, that you understand that, right? So if you have screenshot so that I can erase that. So okay, let me just write on the side. I just shown you that, right? So also you must know this formula here is very useful. It is very useful. This formula there, it is very useful. This one, this is very useful, right? So this formula, we can call this formula, you must know this formula. It is very important, that formula. It is very, very important. It's like, you can call it this formula. It's according, we call it simple harmonic. This is a simple harmonic formula. Harmonic motion. So formula for simple harmonic motion. If you come across, when you read a statement, you come across the word simple harmonic, this formula will use. Let me just write here. Let me do like this. Simple harmonic motion. Okay. Let me just, simple harmonic motion formula. Simple harmonic motion formula is this formula here. You must know that formula. It's a simple harmonic formula. Remember, HS can change, is this one, but you must know that HS can change. This is a simple harmonic formula. HAT, right? It's equal to HS plus H, right? AS plus H separation. Remember, this can change to be what you are given. There might be, will depend, but all you must know that is a H separation. Sometimes it can be things like okay, the H separate. For now, let us click for that H separate. That is a simple harmonic motion, right? You must know that is a simple harmonic motion. This formula, it is useful because you'll use this formula to calculate the speed, because this, remember, this is H due to atmospheric. It's a H due to what? Atmospheric pressure. So in other words, this can be a barometer. What is the instrument that is used to measure atmospheric pressure? We know that we have something, we have types of instrument. You know, we have something which we call barometer reading. It's a barometer reading, right? When you have a barometer reading, right, this will be equal to the barometer reading, and then is measured, this thing H, you must know the energy units of this barometer reading will be measured in meter, must be in meter. Barometer reading will be measured in what? SI units, must be meters, must be in meters, right? That is the barometer reading. Barometer reading must be in meter. This must be in meter also. H, or the acceleration, the H due to acceleration to the suction must be what? In meter. This must be in meter, right? This must be in meter. SI unit must be in meter. Also, this must be in meter. So in other words, we can write this in weight form. In a weight form, let me erase here. You can say, so since this we know HAT is a barometer reading, we can say barometer reading is equal, I put this equal sign, this HS, you must know that HS, that is a suction head, and this one will be what? Suction head. I want us plus, we follow this formula, plus HAS. What is that? We call that, you know, it is accelerating head, right? Accelerating head. Right, we have accelerating head plus this H sub. It's a what? Separation head. It's a head which separate water. Yeah, it's a H which separate water. Right, so you must know that this is just in words form, but this is a simple harmonic motion formula. You must know this formula is very important. When you head according to simple harmonic, you must use this. Why it's important, this formula? It's important so that we'll calculate the speed. If you want to calculate the speed, you must make this the subject of the formula. HA as this the subject of the formula. What I'm trying to say, right? Let me erase here. So you have to come here and make head due to accelerating the subject of the formula, right? If you make head due to accelerating the subject of the formula, you must make it the subject of the formula. Remember, because why? HA due to the acceleration part. Remember, the head is due to acceleration. Accelerating head is given by this formula. Why it's useful? L over G multiplied by area over small area, right? Isn't it? But now we suppose that it's an area over that area, right? Then you must multiply this by angular squared multiplied by r cos theta, right? So if you want speed, remember we want to make this to be the subject w. Remember w is 2 pi n, right? This n is this number was what is way. It's how it will tell us about what speed, which the here is the speed. If it's in second, maybe here will be over 60, but the aim is to calculate this. So that is why we'll use this formula first and make the subject of formula HAS, right? The accelerating head. This, it's what happens in pressure in cylinder due to suction stroke. That this is the suction stroke side. You understand? So you'll see it when we are dealing with question. When we are dealing with question, right? So you must understand that. So another thing you must take note, they can give you that thing those pressures, they can give you in a form like they can give you like in Pascal. If they give in Pascal, remember that is you're supposed to make sure that you convert to pressure heads, right? You must convert it to the pressure heads, because remember must measure it in meters, right? So you know most that formula for the pressure. It's important. They can give, if they give you in kilopascal, let's say they give you atmospheric, maybe they want you to use the simple harmonic motion, right? Use simple harmonic, maybe they give you, they say the atmospheric, maybe say in the question they give you the atmospheric is equal, so we must take note, maybe 200 kilopascal. If they give you 200 kilopascal, this is the atmospheric, but we know from the atmospheric, we know most this is, let me just erase here. I want you to understand this. If they give you this, let's say, let me erase here, let's say they give you atmospheric, they say atmospheric, right? They give you atmospheric, which I'm running out of the ink here in this. Yeah, okay, let me try and change this atmospheric, right? If they give you the atmospheric or the atmosphere, it's up to that atmospheric pressure. right? If they give you atmospheric, let's say they say it is the pressure, maybe it is 100 or 1000 or 200 kilopascal. Let's say it is 100 kilopascal for an example. So this is a pressure. Remember, this one is a pressure, must correspond to the atmospheric pressure. This atmospheric pressure, it is measured in barometric reading, in barometer reading. We'll see this in barometer reading. Now we know the barometer reading is also indicating its head is HAT, right? In our calculation, in our formula, in our simple harmonic formula is HAT. We know that, right? So we want this, but this is the head. This is the pressure. That means you know this formula. Pressure, we want the head. Remember, pressure is equal to what? You must know that it's rho, right? It's rho G. This will be HAT. Why? Is because for the atmospheric is measured in barometric reading, and we know that the head that we have must be HAT, head due to atmospheric. A head that will, in the atmospheric pressure, the head that will occur, we'll call it the head. The head will be atmospheric head. Understand? That will be atmospheric head, which is a barometric reading. It's a barometric reading head. This will be in mid, but this is in kilopascal. You come and substitute here 1000, right? But now you know that is times 10 to the power 3, right? Now what about the density, right? What about the density? They might happen. They will give you the density, or they will give you the relative density, which is the specific gravity. You must also remember your N5 fluid mechanics. Specific gravity is the same. Remember, SG is specific gravity is the same as relative density, right? Whereby we know this is equal to the density of the substance over the standard density, which is of what? It's what? Right, it's what? Right. This is what the specific gravity. They say they give you specific gravity. If they give you specific gravity, we must try to find ourselves the density that is used, the density of the liquid that is used on this pump, or that is entering the cylinder in this pipe, that liquid or that fluid. What type of fluid must be? It can be often they use what it might be a pump slime with, maybe it might be a slime like this way, slime like this. They must use this pump slime. If they give you pump slime, right, you take that relative density, you multiply by 1000, right? You know, let's say they give you relative 1000. Often they like to give you 1.1. If it's 1.1 here, you know, you will say, you lose this formula, right? You know, we come and say 1.1 is equal to P. You want the density, right? Now we want the density. If we want that density of the substance, of the fluid, which is lime, all that lime over of the water, we know that is 1000, right? You multiply this by 1000. P is lime. This is a rho, actually. The density, you multiply 1.1 times 1000, right? You must multiply that by times 1000. This can be the same as 1. Just let me write it in notation form: 1.1 times 10 to the power 3, right? Kgs per cubic, right? This is the density. So since you have the density, you can take this density and substitute in this formula. What I'm trying to say, you can come, you use this formula, right? This formula, P, right? We have pressure, which is 1000 times 10 power 3. Your density is this one, 1.1 times 10 to the power 3. Gravity is 9.81. multiplied by HAT. Now you can calculate what your head can make it a subjective formula. Say HAT. Yeah. Then you make HAT the subject. Now, since you have this HAT, you can use it here on this formula. In case if they give you the atmospheric pressure, they can also give you the index separation. They can give you the temperature. Remember the Viper at they can give you the Viper at the separation. Remember at the separation is below the atmospheric. Here they can give you a Viper. When it's HSAP, at the HSAP, they will give you the pressure of the Viper or of the water. Might be a temperature of the Viper or the water. They will give you of that slime, right? They can give you the Viper of the temperature of this slime, and right. There might be a pressure here. Maybe it will be HSAP. They will give you on the HSAP. Maybe example, if they give you on the HSAP, if they give you HSAP on the separation, they will tell you about the pressure. You also here you have to use this formula. Again, the same formula. P is equal to PG, but your head now, remember, will be H2, will be HSAP. The separation. You substitute, you use this formula, you substitute it there, you play around with all of this stuff, right? Then you'll be done. This is only, we're focusing on what this was a suction stroke. And then you must note that the separation only occurs, at the suction. This HSAP, this I have to know. You must understand that. We must understand this, that HSAP, the H separation, HSAP only occurs at the suction stroke. Do not use it on the delivery stroke. No, there is no HSAP. Hopefully you understood this, guys. Then stay tuned as I'll be explaining the delivery stroke in the pressure in the cylinder. Now we did the suction stroke, and then the simple harmonic takes place in the suction stroke, and then the suction and then the simple harmonic formula is this one, right? Cool. Okay, guys, don't forget to subscribe and stay tuned, stay notified as I'll be posting the next video on the delivery stroke. Remember, we're still under the pressure in the cylinder. What is important for you is to understand this formula. Is this formula only. Everything will be given on the statement. Understand this, understand how to operate this formula. You're good to go.